Hi, welcome to our MAE 301 Applied Statistics project experiment. We are team number 2. Our experiment is called Bounce Height of a Tennis Ball. Here's a brief introduction of the physics behind dropping a tennis ball from a height and recording its bounce off a surface. When the ball is first dropped, it has a high potential energy, and as it reaches the ground and bounces, it experiences a large amount of kinetic energy. As the ball makes contact with the ground, it experiences a force from the ground which pushes it back into the air. The objective of our experiment was to analyze the effect of different surfaces on the bounce height of a tennis ball. And also the experiment analyzed how the initial drop height also affected this rebound height. So again, the two factors that affected the rebound height are going to be the initial drop height, and we recorded 3 different heights from 5 feet, 4 feet, and 3 feet. And then the other factor is going to be the surface. And our 4 surfaces are tile, concrete, wood, and carpet. Our null hypothesis for this experiment is that the average bounce height for each surface will be approximately the same. Now, alternatively, our one bounce height, average bounce height, is different, then we will claim that there is an effect of on bounce height resulting from the surface. Here's our experimental design. As I stated previously, we have 3 different initial bounce heights, 3 feet, 4 feet, and 5 feet. And we have 4 different bounce surfaces: carpet, wood, tile, and concrete. In total, we will have 36 different trials. The setup for our lab experiment is a fixed ruler positioned vertically against a wall and a camera positioned normal to the ruler, which records the bounce height of the tennis ball. Now, during our testing, we selected multiple different locations, and the location of the test was picked to accurately represent the surface the best we could. The test drops that were conducted before our actual recording took place was done so in order to decide where to position the camera so we could get the best shot of the resulting bounce height. Our measured bounce height was recorded at the apex of the tennis ball's bounce. And then our video was recorded in slow motion in order to best capture this bounce height. Here is a video of this to better visualize our experiment. As you can see, we did our best to measure the max height of the ball when it reaches a velocity of about 0. Now, despite our best efforts, we did run into some problems during the experiment. First, we had some inconsistency in our trials due to uneven surfaces on our, and also we had a hard time measuring the numbers on the ruler in certain videos. And when we ran into these problems, we we redid the trial to correct the issue and keep our results consistent. Here's a look at our data. The most important things to point out here is that our minimum height recorded was for the carpet, which is interesting because the carpet also has the lowest density. Now, on the other hand, our max height recorded was on the tile, and the tile has the highest density. It can also be observed that the tile and the concrete have very close results, and they also have a very close density. And last, it should be noted that from the initial drop height of 3 feet, wood, concrete, and tile all have very close results. And it isn't until we dropped the tennis ball from 4 feet where we started to see some significant changes in the bounce height between the surfaces. Here's a look at our regression models. As you can see, the line of best fit for each trial appears linear. For further data analysis, we performed an ANOVA test on our data. This was done on MATLAB and with a confidence interval of 0.05. The ANOVA test proved that it is highly likely that the surface affects the bounce height. As you can see, each p-value we found is much less than our confidence interval or confidence level 0.05. In addition, we performed a Cherky analysis to compare the effect of each surface. From this analysis, you can see that at 3 feet, concrete, tile, and wood all had about the same bounce height, and there wasn't much of an effect on when the bounce initial drop height was at 3 feet. Now at 4 feet, we found that concrete and wood had a similar bounce height, but between wood and tile and carpet, the surface started to have a much more significant effect on the bounce height. And this trend is more obvious in our last one here at an initial bounce height or drop height of 5 feet. And the only two surfaces that were similar were concrete and tile at initial drop height of 5 feet. 3 of the surfaces were all experiencing different rebound heights, except concrete and tile were still pretty similar. We had some difficulty in producing a large enough sample. This would have been very time consuming, and it would have been difficult to do this for a bunch of different surfaces. It was difficult to keep the data consistent while using a camera to measure the height. And a lesson we learned is that density seems to have an effect on rebound height, and that better equipment will result in more consistent results. In conclusion, we will reject our null hypothesis due to the ANOVA test that we ran. Therefore, we will claim that the surface from which the tennis ball bounces does have an effect on the rebound height. Now, it should also be noted that the higher density surfaces resulted in higher bounce heights. And also, as we drop the tennis ball from higher initial drop heights, there was, as a result, a higher bounce from the tennis ball. Thank you very much for listening to our laboratory experiment for applied statistics.